Okay, somebody give me an example of a monoprotic acid. Okay, sure. CH3COOH, acetic acid, because that's the only acidic H. How about a diprotic? This is a special diprotic. Why? I didn't. Something another time. What? Yeah, that's what diprotic means. But why is this a special diprotic? Carbonic is a diprotic acid. Why is this a special diprotic? The first one's strong, and the second one's not strong. Okay, and a triprotic? Okay. And all three of those guys can come off. What about these? Why are those not acidic? There's no polarity difference there for the hydrogen. The hydrogen is connected to a carbon. It's not connected to an oxygen that's also connected to a carbon that's doubly bonded to an oxygen. So it's not acidic because it's not. There's no polarity to it. Okay. I don't know why this one got a bunch of questions. It's really no different than any of the other ones we did, but whatever. First thing we need to do is figure out how many moles of each of the species that we've got. So I've got 1.2 mole per liter H plus, and it's 0.05 liters. So why am I just writing an H plus there? Yeah, because this thing's a strong acid, so the bromine doesn't matter. It really doesn't matter. Already, and then I've got 1.26 moles per liter HA and 0.5 liters, because that's the total volume of the buffer. So what do I have here? Why is this HA? Because it's an H, and then the rest of this, when the H comes off, is what? It's an anion, and anions are negatively charged. So we'll just use HA as the generic weak acid form. And then I've got 0.5 mole per liter A negative and a half a liter. Okay, so why is this one just A negative? Because why? That sodium's just going to fall off, correct? What's left behind? An anion. We don't really care what the anion is. It just needs to be an anion, yeah.
I don't think it changes the math, but don't we have those mixed? There's 0.5 of the phenols and 1.26.
Oh yeah, I totally got those guys backwards. Thanks. This one is 0.5 and this one's 1.26. Okay. What is this? 6D into. Is that right? Or is it just 0.2? No, it is 0.06. And this is 25.25. HA 1.26, 0.63, A negative. All right, so I've got a weak acid. I've got the conjugate base of the weak acid, and I have initial amounts of 0.25 and 0.63. I'm going to change that, and then I'm going to end up with an equilibrium. What did I add to this buffer? An acid. So this is my acid. So this is going to go up 0.06, which means my base is going to drop 0.06. And so then I end up with 0.31 and 0.57. So then my pH log plus it will be 0.63 divided by 0.25. Wait, sorry. This 0.6 plus 0.63 divided by 0.25 equals Okay, we are with that. Trying to explain the titration curve of strong acid being titrated with a strong base. Okay. Anything you want to add to that? Milliliters of titrant. So in this case, you could say milliliters of sodium hydroxide. Or just hydroxide.